and that's what I'll do. Okay, not really anything that is very, very, serious, just in general stuff that I think would be kind of important to go over in a class. This class has 44 students still, enrolled, okay? Of the 44, okay, do you guys have any questions in the back?
Sorry, I was sneezing.
Okay, all right. Now, the first thing was, of a class of 44 students, 26 have not clicked on the link that we were talking about last Thursday. Okay? Now, it's not very encouraging, from your perspective, not from my perspective, because, I know some of you have some programming background and this is not really, difficult stuff, but it really still helps to kind of read it, because I am pretty sure that there's some material in the lecture notes that you have not seen before, because I don't think any other class will teach you how to trace a program the same way that I do in this class. So it will still be beneficial to kind of go over the notes before the class as well as after the class. So I think it is important to review the material, after the class and get ready for the next class. And 26 people have not done anything with the material that we have gone over, last week. I also know that no one has seen the YouTube clips, because once, since I have uploaded the YouTube clips, no one has clicked on it. Okay, when I look at the number of views, it was 0. Okay, so I just feel that I need to nag you guys a little bit, just so that you guys know. Okay, spend some time to read the notes. You don't have to read the whole thing. Spend 15 minutes, just kind of glance over the material that we are going over. Yep.
Where's the YouTube channel?
It is just go to YouTube. Okay, this is how you do it. I demonstrated that last time. You go to YouTube, you type in cisp300, which is the course code for this class, and then you type in the date code, which is 2011. If you want to look up the video clips for today, it's going to be 0125, which is January 15th. But if you want to look up stuff from last week, the 20th would be the one that is only available, because I did not record anything on the 18th. Okay? So this may be helpful if you don't want to, actually read the material. You can just kind of go through the video clip, a little bit, and at least, kind of remind yourself, what we have talked about so far, and also go to the end of the video clip so you know what I will be starting to talk about today. Okay. Are there any questions about this part? Yes, sir.
Is there a space between 300?
Yes, there is a space. Basically, cisp300 is the name of this class, and this is the date of the class. You can actually find lecture notes or lecture recording from last semester. I recorded all 3 sections of cisp300 last semester, so there's plenty of recording. If you kind of look back in time, you can see how I taught the class last semester. And you will also find solutions to homework assignments from last semester, as well as questions and answers for the exams from last semester. So you might want to do that before I remove all those video clips. Any questions at this point? No questions? Okay. And starting with this semester, I'm not going to send a playlist or a link to a playlist to my video clips, because I already showed you guys how to locate the individual clips. So if you want to make a playlist out of the entire day of lectures, you can basically string all the video clips together and make your own playlist in YouTube. And just a mild reminder that we have a homework assignment due on Thursday. If you have not worked on the homework assignment, you might want to take a look and see what it is involved. It's really easy to do. You can do it over in the lab in room 152, so you don't even have to do it on your own computer for this one. Well, all of the homework assignment in this class, you can do it at the lab. Does everybody know where is the lab? Room 152. If you walk out from this door, you make a left turn. It is on the other side of the boat fountain. Okay. Are there any questions about the location of the lab? Room 152.
You
Yes?
have to verify you're in the class, correct?
Yes.
Okay.
Mm-hmm. But as far as I know, there's no one waiting on the wait list anymore. Is anyone on the wait list at this point? You're still on the wait list? I'm pretty sure that you can add to the class today. So I'll let the class pass the row sheet around, so I can take row this way, and I'll start on the topics now. Last time we talked about the assignment statement, which is the most basic statement in pseudocode. And the way I represent an assignment statement is not to use the equal symbol, but to use the left arrow. The reason is, why did I do this? I kind of explained that at the very end of the last class. It has to do with the equal symbol has two meanings. One meaning in programming is assignment. Most programming languages would use the assignment operator or the assignment or the equal symbol to mean assignment. But it is also confusing because in mathematics, if you ask your math professor, what is this? What is the meaning of x equals x plus 1? Your math professor will tell you it is false. It is not true. Because it doesn't matter what value you pick for x. X cannot equal to x plus 1. Is that making any sense? Okay. But in programming, the equal symbol is not always meaning equality check. Sometimes it means equality. Other times it is the meaning. It has a meaning of assignment. Okay, and assignment is what we were talking about last Thursday. An assignment statement has a left-hand side, this part here, also a right-hand side. The way you evaluate an assignment statement is you start with the right-hand side. You look at the right-hand side, you evaluate the value of the right-hand side. Once you have a value for the right-hand side, you use that value to update the left-hand side. The left-hand side is over here. And that's why I use a left arrow to basically indicate you have to evaluate the right-hand side and then you update the left-hand side. Now, when you look at it that way, then this makes sense. Okay, because what we are doing is we're taking the current value of x. We add 1 to it, it becomes a new value. What do we do with that new value? We use that to update x itself. It is not circular, because once you update x, you move on to the next statement. Okay? Are there any questions about the nature of an assignment statement? No questions about, yep, go ahead.
Does that mean it's like basically x plus 1 equals x plus 1?
No, it means if x has had a value of 2, it now has a value of 3 after this statement executes. Okay? Any other questions about this? Okay. So we'll go ahead and talk about assignment statements in general. A lot of this is actually a repetition of what I have already said. An assignment statement is a step that updates the value of a variable. It is usually expressed as the left-hand side gets the value of the right-hand side. The left-hand side specifies which variable we want to update. The right-hand side specifies the new value. The symbol, the left arrow symbol, indicates the direction of information flow, which is from the right-hand side to the left-hand side. Okay, I know this is a little bit counterintuitive because we want to read from left to right, but this is almost a universal standard in programming. In almost every single programming language, when you have an assignment statement, you evaluate the right-hand side and then you update the left-hand side. So that's why I kind of keep that convention of the right-hand side specifies the new value, the left-hand side specifies what do you want to update. Note that the symbol left arrow is replaced by an equal sign in most programming languages, and that includes C, C++, Java, Perl, PHP, Visual Basic, and just about any modern programming language, except for Pascal, would use a equal sign to mean assignment. But that can be extremely confusing when you move on to cisp300, because if C is using the equal symbol to mean assignment, what do you think it will use to mean equality check? Double equal. Okay, so there's equal and double equal in C. Now, let me ask you another question. Do you think it can mistakenly use one instead of the other one? In C, you can, but in Visual Basic, you cannot. Okay? So we'll get into those topics later on when we start to talk about conditional statements. The key to an assignment is you always evaluate the right-hand side first, and then you update the left-hand side, and then the entire statement is done. Okay, so it's just a two-step process. Yeah, it's kind of loud. Is it the next room or outside? Outside. Well, we're trying to keep it loud. Okay, thank you. If you guys overheard the actual content, you can actually tell me so I can tell the student, well, my advice is, don't buy that car or something like that. Just to annoy the heck out of her. Okay, so this is a very simple assignment statement because the right-hand side is a constant. It is a 0. What happens when we execute this statement is exactly what I told you guys in the previous slide. You evaluate the right-hand side, which in this case is a constant. 0 is 0. And then you update the left-hand side, which is a variable that we call AE total expense. So this means whatever value AE total expense had before this statement will be cleared after this statement. After this statement, AE total expense will have a value of 0. And there is no way for a program to retrieve a over and overwritten value. After this statement, there's no way you can retrieve the old value of AE total expense because overwriting is irreversible. Is that okay? Okay. So remember that once you overwrite the value of a variable, there's no way to go back to find out what it was before the statement. The next statement is something that we have talked about already. It's just, AE total expense gets AE total expense plus X. It looks a little bit confusing because, once we update AE total expense, doesn't that automatically change this part here and then we have to reevaluate everything? And the answer is no. It is just a two-step process. 1, evaluate the right-hand side. 2, update the left-hand side. And then you move on to the next statement. Okay? So there's no circular reasoning here, even though it looks like it is somewhat circular because once we update AE total expense, don't we have to reevaluate the right-hand side? And the answer is no. You do not reevaluate the right-hand side. And I have meant to change this part here. Well, I think this one is still correct. So that means if AE total expense has a value of 263 and X has a value of 71 before the assignment statement, after the assignment statement, AE total expense will have a value of 334. Is that okay? Exactly, what it should have, the way it should happen. Section 5 is about visualizing variables and how they get updated. Now this part is somewhat unique to this class. This is a technique that you will learn in this class because I want to make sure everyone in this class can run a program on a piece of paper so that you have a really good understanding of what happens when a particular statement executes. So the question is, when you execute a program, how can you keep track of the value of the variables? Let me give you an example. Instead of using the whiteboard, I would use an editor. So this way, whatever I do will also be captured by the video recording. And I think I need to erase one of the files because there won't be enough space if I don't do that. So let me first find out what files I can erase, and then I'll go ahead and erase those. So everything from last week I can erase. Now I have enough space for today. Okay, so here's a regular text editor, and what I will do is I'll give you a very simple program. This is the way I draw a left arrow in text. because when you're using a plain text editor, the left arrow is not one of the characters that you can type in. When you use Word or Excel or OpenOffice Calc or OpenOffice Writer, you can actually select the left arrow character so that it looks exactly like a left arrow, but not when you're using a text editor. So that's why I use a less than followed by a minus symbol to mean the left arrow symbol. So let me just give you a very simple program, and we'll go ahead and keep track of the values of x and y.
Is that theta or 0 on the top line?
That's 0.
Oh, that is 0.
Yeah, it's a plain text editor. I cannot enter theta. So as a general rule, we cannot have Greek symbols or anything that's special. This is a plain text editor. Okay, we'll just make this the end of the program. Well, you can see that you can actually do this in your mind. In other words, you don't really need a piece of paper. I can actually just reason it out, and I say it, and my brain can keep track of the values of two variables without much problem. After the first line, whatever x had will now become 0. The second line will evaluate x plus 2 first, but since x has a value of 0, that means x plus 2 is 2, and y will now be updated to a value of 2. On the third line, x still has a value of 0 at that point. 0 plus 2 is 2, and x will now be updated to 2. After the third line, x and y are both 2. On the fourth line, y has a value of 2 before that line. 2 plus 4 is 6. So after this line, y will end up with a value of 6. On the fifth line, I'm overwriting x with a value of 20. So I will be replacing the value of 2 with 20 on line 5. On line 6, I am subtracting 10 from x. And since x is now 20, 20 minus 10 is 10. And as a result, y will end up with a value of 10. And as you can see, you can probably do the same thing too. I mean, keeping track of the values of two variables is not too much of a problem. Most people can do that, in their mind. But in this class, we don't want to do it, in the mind. We want to actually do it with a trace that we can go back step by step and say, did I make a mistake on line 4? Did I make a mistake on line 3? So this way, everything is step by step, and we can actually, go through the entire process, and we can double check everything. So what I will do instead is not to use a text editor, and this is why I want you guys to use OpenOffice Calc, because we will use that as a tool so that we can keep track of the execution of a program step by step. For the most part, I am not using Excel for any type of calculations. I'm only using Excel to keep track as a table. It's a very expensive way of maintaining a table. The way I usually teach this class is I will use sheet 1 for the algorithm itself. I will use sheet 2 to actually perform the trace. So this is something, this is also, it will involve a technique that you might want to remember or take notes of, because you will have to do this at home for the next homework assignment. The first step isn't much. Okay, I will just copy and paste this code into Calc. Copy, paste. That looks good. But in Calc, I can actually do a little bit better than the approximation of the left arrow, because it automatically converts the approximation of left arrow into an actual left arrow. So I'll go ahead and just make it look nice like this. Yep.
Would it be considered wrong if you just left it that way?
Sorry?
Would it be considered wrong if you left the arrow as you would in
No,
the-
that's perfectly fine.
Okay.
Yep. So you do not have to replace it. I just kind of want I want to use the left arrow because it looks a little bit better. That's a good question. In this class, as long as I know what you mean, it's going to be okay. In other words, for people who want to spell out and say, y gets a value of something, that's okay too, but that really takes a lot more typing than using the left arrow symbol. And you can also see that, the x and the y's, they all get capitalized. So one way to stop it, because all of you will be using OpenOffice Calc, is to go to Tools and go to, let me see, Autocorrect Options. And what you want to do is to go to Options, and then you want to turn off most of these things. So you want to use replacement table, but you want to basically fix the other ones and just turn off everything else. So when you turn off everything else, then you can say x gets 20, and it will not go ahead and capitalize x. In this class, whether you capitalize or not, it's not that important. But I still like everything to be consistent. Lowercase is lowercase, uppercase is uppercase. I'm not going to spend too much time to go back and fix this one since it is only an example. Column A has a different purpose. So what I do with column A is column A indicates the line number. You can say, but the line number is the same as the row number, and you're perfectly correct in that case. The question is, when you print this out, do you want the line numbers to print along with the program? If you do not have column A to indicate the line numbers, when you print out this particular sheet, then the line numbers won't print. Okay, unless you configure OpenOffice Calc to print also the row number as well as the column number, which is fine. Okay, let me just show you what I mean by that. When you go to File, and then you say Page Preview, which means I'm going to print the program. And let me change the zoom ratio so we can see better. So this time, when I print it out, if I print it out, it will print the line number along with the actual code on those lines. If I do not have a column for line numbers, then the line numbers won't print because they're just row numbers for the spreadsheet. So this is why in the class I always explicitly use one column for line numbers. Oh, that's not what I meant. No. How do I get out of here? Format page.
TV picture?
No, it's too big. The toolbar is too wide. So it's not showing closed preview. Okay, now moving on to sheet 2. Now, since this is the first part, and what I would usually do in the class is all the examples that I do in the class, I will save it into a folder. At the end of the class or at the end of the day, I will zip up the entire folder and put it up to Moodle. In other words, you don't have to spend your time, busy, copying whatever I do on the whiteboard or on the projector, and you can just kind of focus on the process instead. And I always use a folder with the name of today's date. So in this case, it is the 25th of January, and this is cisp300. And later on, I will upload a zip file of this entire folder. Okay. And I will name this simple assignment because that's all it's illustrating is how do you do simple assignment. Now, I have a task to do that because I want to trace this code but on a separate sheet. Sheet 1 is only the algorithm. Sheet 2 is the trace of this algorithm. One trick you can do in OpenOffice is to use Window and then select New Window. So now we have two windows of exactly the same document. When you look at the screen that is behind and also the screen that is on top, they are two different views or two different windows of exactly the same document. I can illustrate, why I say that. Let's say I go to line 5 and fix the capitalization and change that back into lowercase. You can see it is changed here as well as here. That basically shows that these are two windows of exactly the same document. Now, in the second window, I can now switch to sheet 2. And it won't affect sheet 1 at all. And now I can look at the code and trace the code at the same time. Are there any questions about these techniques of using OpenOffice Calc? Yep, go ahead.
Yes, did you just go to File, Window?
It's Window, New Window.
Oh.
So you go to the Window menu and then you select New Window. That will open up a new window of the same document. Okay. And since I messed up the print preview because I zoomed in too much, so let me go ahead and try to fix. Oh, it won't do it. Okay, I can now close this document because I don't need to save that. Oh, I just closed the wrong window. Okay, that's okay. I can tell the way it's printing is incorrect because it's zoomed out too far. So I just want to readjust it and then close the print preview. Go to Sheet 2. Now, the trace also has a very specific format in this class. There are certain columns that has to be there. The first column that has to be there is what I call a line number column. And then the other two columns in this case will be one for each variable. We have two variables in this case. One is x and the other one is y. So for tracing this particular program, we only need 3 columns. Okay? Any questions about why we have 3 columns? No questions? Okay. The first line is what I call a pre-line. The pre stands for precondition. In other words, before we even execute line 1 of this algorithm, do we know anything about x and y? That's the question. Most of the time, unless I tell you that we know ahead of time that x starts with a particular value or y starts with a particular value, you assume that you don't know anything about x or y. And the way we state that is to put a question mark under x and another question mark under y. This is basically saying before line 1, before this entire algorithm executes, we don't know anything about x. We don't know anything about y. They can be of any value before we start the execution of this code. Is that okay so far? Okay. And then we start with the execution of line 1. Okay. We put a 20 into here and a question mark into here. Now let me go back to cell B3 and explain why B3 has a value of 20. Cell B3 is telling you what is the value of variable x after the execution of line 1. That is why it has a value of 20. Is that okay? Okay. Yes?
But did you want to start with 0 because you had it originally, or do you want to start with 20? Because then you're just going to overwrite 5, right?
You could have started with some known value because we will just go ahead and overwrite it. So for this program, if you start with some known values, that would not change the behavior of the program at all.
Gotcha.
But in general, if I don't say anything about the initial value, they start with some unknown value. Very good. Good question. Okay, but nothing happened to y on line 1. Is that right? Okay, because the assignment statement is only using x on the left-hand side, and only x is modified in this case. Y still has the same unknown value as before. Then we move on to line 2. On line 2, y is the one that gets updated. So that means x will retain the value of 20. It does not change, but y is going to be overwritten. What do you think will be the new value in y?
22.
Y will be 22. Very good. Okay. Because we evaluate what is x plus 1, x has a value of 20 at a time. 20 plus 2 is 22. And we use 22 to update y. And as a result, y is now has a value of 22. So the important part of this format is we only record the value of variables after that line executes. Okay, the line number is line 2. The value after line 2 is 22. Is that okay? We are only recording the post-operation value of a line when we record it in the trace. The rest should be fairly easy because now we move on to line 3. Line 3 is adding 2 to x, or x gets x plus 2. So what do you think will happen to x?
22.
X ends up with a value of 22. And what happens to y?
22.
Nothing happens to y, so it retains its old value of 22. Moving on to line 4. What do you think happens on line 4? What happens to x? Okay, nothing happens to x, so it has the same value as before. What happens to y?
You have 4.
So it becomes 26. Okay. And on line 5, what happens on line 5?
X gets replaced by 20.
X gets replaced by 20. What happens to Y? Stays exactly the same. So this step here is kind of important because once you update, okay, let's go back to line 2. Okay, once you execute line 2, Y has a value of 22, but it is now decoupled. It does not relate to X anymore. In other words, the value of one variable is independent from the value of another variable. Is that okay? Okay. Because otherwise, on step 5, when we change the value of X, Y, some people might think that Y will change as well, but that is not the case. We are now on line 6. Line 6 evaluates X minus 10 on one side, and we use that to update Y. And what do you think will happen here?
I will switch to 10. X stays the same.
Okay. Well, X has a value of 20 at this point. It does not change. And 20 minus 10 is 10, and as a result, Y is now updated to a value of 10. Okay. Line 6 is the very last line of this program. After line 6, I always use post to mean that, okay, we are all done with this algorithm. And that's the way I trace programs in this class. Are there any questions about the convention? Any questions about any particular value in any of the cells here? No questions? This is all easy? Okay. Yep, go ahead.
Will we ever have preconditions for the values?
Yes, sometimes.
How would those look on sheet 1 then?
On sheet 1, you cannot see anything. You in the question, I will basically say, assume a variable X starts with a value of blah blah, and assume variable Y starts with a value of something else. Yep, go ahead.
Is X always on the left side and Y is on the right side?
No, they can flip. It doesn't matter. Okay. Any questions about this? No questions? Okay. So what I'll do is I will save this file. So now it has a copy. Okay, I better turn off my phone so it doesn't distract the rest of the class. Sorry about that. Okay. And there's one more thing you can try to do. This part is definitely optional. You can see how column A, B, and C are taking up more space than they should. One quick way to make them as narrow as possible and still show everything is to select all the columns. Okay, you just shift click to select all the columns, and then you double click once the icon, once the mouse pointer changes to the double-sided arrow like this. You just double click, and it will automatically shrink the columns to become the optimal width. So just little tricks. You don't have to learn all these tricks at this point, but if you want to practice all these tricks, you can go ahead and practice it. Excuse me, I'm trying to teach a class over here. Well, I thought I said bye. Yeah, but you're still yapping. Okay, so getting back to here. Are there any questions about this trace? This is a very simple trace.
Could the precondition be like X is greater than 10 or something like that? Could that be, is it going to be specifically the value?
No, I know what you're talking about. You're talking about, what if we know ahead of time that X is greater than Y or something like that? You want to express a relationship between the variables from the beginning. We are not quite there yet. What you're asking will be answered in the section called pre and post conditions.
Okay.
Yeah, so we will get to that point, but it won't use the trace representation. We'll actually use more of a math representation in that case. But that's a very good question. We will get to that point. So let me go ahead and close this. And make sure we save the document. And basically that's just exactly the same thing that we talked about. Okay. Any questions at this point? As I said, I don't always just repeat the examples that I have in the notes. A lot of times I will use additional examples in the class to illustrate the same concepts. So that's the end of the first module. We are done with variables, expressions, and sequences. Now we are moving on to conditional statements. And you will have a new homework assignment on Thursday, about the material that we have covered up to this point. So it is kind of important for you guys to at least go back and read the notes again, just to make sure that you don't have anything that you don't understand. So this module talks about conditions, conditional statements, and in general, how do we deal with logic in a program. The first question is why? Conditional statements are important because they permit a program to follow different paths based on the outcome of conditions. In other words, conditional statements give your programs the ability to choose what to do next. Because at this point, we have talked about the very first and the most important type of statements, which is an assignment statement. Without assignment statements, your program really cannot do anything. It is meaningless to have variables without assignment statements. But even with assignment statements, at this point, your programs can only be a straight line. In other words, you can have one assignment statement followed by another assignment statement, followed by another statement, followed by another assignment statement. You can specify how you want to update the variables in a sequence, but you cannot make any decisions. You cannot say, at this point, sometimes I want to go on this side and sometimes I want to go on the other side. There's no way you can make a decision at this point. And that's why we want to talk about conditional statements, because that's a mechanism to make decisions in the program. But before we can talk about conditional statements, we have to talk about what is a condition. And a condition is essentially a question that can only have one of two possible answers, either true or false. I choose the words, true and false instead of yes or no, because in natural languages, sometimes it can be confusing. Okay, so we don't use yes or no, we just use true or false. You can read the rest of this paragraph here. I'm going to skip it. I'll just kind of say that we will only use true, false as answers and not yes, no. The most common type of operators that will return a value of true or false are comparisons. I don't think there's anything really new here. I'm hoping that everybody already know these operators. The first one is greater than. In other words, if I give you x greater than y, it is not a statement in a program. Okay, let me just do that with a with a text editor, so I can show you exactly what I mean by that. Okay, when you see something like this, x less than y, in a program, it is not a statement saying that x is in fact less than y. This is a question. It's a question of, is it true or is it false that x is less than y? Okay? Because in math, sometimes when you see a statement like this, it is a statement. It tells you that we already know that x is less than y. But in programming, it is not a statement. It is not telling you that x is in fact less than y. It is a question. Is it true or is it false that x is less than y? And then we have the other operators. We have greater than, we have less than, we have greater than or equal to. If you do not know how to enter this symbol, yep, go ahead.
You said there's a question. How do you make a statement say that x is less than y?
We will get to that point. Yep. So we will talk about conditional statements, which make use of those questions. Okay. So at this point, we just know that there will be questions, but we don't quite know how to utilize those questions at this point. Okay. X is greater than y. Well, are there any questions about the differences between greater than versus greater than or equal to? No. Go ahead.
I think he wasn't asking about the conditional statement. I think he was asking if you can use that like an assignment.
Oh, is that your question?
I don't know what he said.
Okay, his question. Okay, let me show you what he meant. Okay, this is good. I like that discussion because this is something that you will see eventually. Okay, let me give you this really simple program here. X gets a value of 2, y gets a value of 3, z gets a value of x is greater than y. Okay, now what is happening to z? Okay, after line 1, it's easy. X has a value of 2. We don't really care about the value of y or z. After line 2, we know x has a value of 2, y has a value of 3. What about line 3? After line 3, what is the value of z? Z, it becomes false. Very good. Because x is greater than y, returns a value of false. And because x is greater than y is the right-hand side, we use that to update the left-hand side. As a result, z as a variable will get a value of false. Okay, but this is a fairly advanced concept. We don't need to deal with this, for a few more chapters. But that's a good question. Was that your question?
No, but it helps too. So
It's not a bad exposure. It's just a little bit ahead of time compared to the timetable that I had laid out. But that's a valid question. Okay. And then we have less than or equal to. We have not equal to. Now, you also want to kind of read this part here because it may be difficult for you to find out, how to enter greater than or equal to as one single symbol. If you don't want to bother with that, just use 2 symbols instead to represent greater than or equal to. Use 2 symbols to represent less than or equal to. Not equal to has many ways to represent. Most programming languages other than C will use less than or greater than to represent not equal to. Does that make any sense?
Yeah.
Yep.
It makes sense. What do you prefer for this class?
It doesn't matter. As long as I can understand, you can use any one of these representations. And of course, the last one is equal to. Now, this is just, this paragraph here is for people who want to move on to cisp300. This is something that I just talked about. In C and C++, and also in Java, a single equal symbol means assign it. A double equal symbol means equality check. And they mean entirely different things. Unfortunately, in C, you can also accidentally use double equal where a single equal is expected. You can also use a single equal where a double equal is expected. In other words, you can mistakenly use the wrong one in your program. They're both syntactically correct, okay? Even though you might think that it is not actually, does not make any sense. But they're both syntactically correct. It's just that your program will not do what you think the program should do when you use one instead of the other one. So make sure, when you move on to cisp300, pay attention to which one you're using, particularly in a conditional statement. Make sure that you use double equal when you mean equality check, because you can use an assignment operator in place of the double equal. It just do something that is not the same as what you want it to do. Okay? Now, since this is not about C, this class is about pseudocode, I will only mention it once, because you will get to see this, you will make 1 or 2 mistakes in C and C++, and you will remember that after that. Okay. So the next statement, or the next slide, is making use of these conditions to do something that's relatively easy. We will talk about logical operators. The logical operators that we'll talk about consist of only 3 that you use in regular English, and almost every single natural language has the equivalences of these 3. One is and, A-N-D, one is or, O-R, and one is not, N-O-T. Those are the only 3 logical operators that we really need in terms of programming, or just about in any type of logical statements. We'll talk about that next, or in the future. But for now, we'll start to talk about what a conditional statement is. So don't pay much attention to the notes here, because what I'll do is I'll use the whiteboard to illustrate an example. In other words, I probably should hide this first. And so this is something that you might want to write down, because there's a picture somewhere else, that represents the same thing. But it may be helpful to, just take some notes at this point. I want to write an algorithm to find out of two variables, which one is the maximum, which one is the larger one, and I want to copy that value of the larger of the two to a third variable. Let me give you a few scenarios so that you know what the program is supposed to do. The scenario is like this. Let's say x starts with a value of 2, y starts with a value of 3. If I want z to become the maximum of these two, what do you think is going to be the value of z?
5.
Maximum?
3.
3. Okay, very good. If x equals to 3, y equals to -1, z would equal to 3. Very good. What if x equals to 2, y equals to 2? What is the maximum of 2 and 2? 2. It's just 2. Okay, so you guys know what the maximum is. The question is, how do you express this in logic, in a program, in an algorithm? Well, we can't just rely on assignment statements anymore. Because if you just rely on assignment statements, okay, if you think about it, okay, I'm going to use the other side of the whiteboard. If you think about it, we know that sometimes z gets the value of x. Okay, very good. We know how to do that. We also know that sometimes z gets the value of y. Great. So we know that sometimes we have to go this way, sometimes we have to go the other way, but not both ways at the same time. So now if you draw this as a trail map, okay, the trail map has two branches. It has two alternatives. After these two alternatives, they would merge. So we will come out exactly one way, but when we get in, we have to make a decision and say, do we want to go to the left-hand side, or do we want to go to the right-hand side? So the path is going to look like this. Okay, look at this as a trail map. You can come in here, and every way is one way only. The question is, how do you make a decision right at this point, this junction here? In other words, if I'm going to put a sign next to the trail with a question, and let's say I label these two paths. I label this path true, I label this path false. What do you think I should be asking here?
X is greater than y. If
Okay. Wouldn't that be good enough?
Yes.
In other words, before I get to the branch, I would ask a question. Is it true or is it false that x is greater than y? Well, that question can only have one of two possible answers, either true or false. If the answer to this question is true, I follow this path, which is labeled true. In that case, I copy the value of x to z, and then I get out of the statement. On the other hand, if x is less than or equal to y, I take the false branch, and then I will copy y to z, and then I will also exit. So this is a conditional statement, okay, in a pictorial form, in a graphical form. Are there any questions about the code in a graphical form? No questions? Okay. The most important part is you can only take one path or the other. And you cannot determine which way to go until you actually know the value of x and the value of y. So that's a runtime decision. Only when you run this code, you can determine which way to go. Is that okay? But this will be kind of like a flowchart thing, and you know that I do not like flowcharts. So the question now is, how do we change and use pseudocode instead of flowchart to represent exactly the same thing? Well, you already know it. You already know it because it is already in the notes. This is the pseudocode representation of exactly the same logic. The statement starts with a keyword if, and then it is followed by a condition. In this case, the condition is x is greater than y. The then part here is kind of optional. If you guys don't type in the then, it's still okay, because I can still understand what you mean. between the if and the else, you have to state what do you want to do if the condition is true. Between the else and the end if, you have to state what do you want to do when the condition is false. Is that okay? So you can see how this program here, listing 1, is equivalent to the picture that I have drawn here. Are there any questions about the conditional statement, the nature of a conditional statement, as well as the form or how it looks like in pseudocode as opposed to how it looks like in a picture? Today is one of the very few days that I would actually draw a picture of a conditional statement, because after today, I will only use the pseudocode representation. Any questions? Yep, go ahead.
Why does it have end if on line 5 instead of just end?
The end if is here to mark the end of the statement. Obviously, it is not always needed because in some programming languages like Python, they use indentation alone to indicate what statement is containing what other statement. But in this class, I use end if to close a statement. In other words, that's a very good question. If you look at the word if as an open parenthesis, end if is like a closed parenthesis. It explicitly closes this particular statement. Okay.
So end wouldn't be enough, or you want the end if?
I would like end if in this class, because by the time we are done, we will have also while and subroutines and all the kinds of stuff like that. This makes it a little bit easier to match. Okay, what is this end ending? Yep. In a real programming language like C, you just use a closed curly brace, and it closes the open curly brace. You don't even know why you have an open curly brace. But in a class like this, I just like to make it a little bit more explicit so that it's easier to keep track of stuff. But if you type just end, in this class, I would still accept that as long as the indentation and everything else, matches up. Okay. Are there any questions about this statement here? No questions? Okay. So the next question is, well, this is what it looks like in pseudocode, but how do we trace an algorithm like this? Because remember, our previous example is just a sequence. Okay, one step follows the next one, follows the next one, and that's why in terms of line numbers, we go from 3 to 1, 1 to 2, 2 to 3, and etc. Not very exciting. In this case, we are not going to do something like that because sometimes we skip statements. So let's go ahead and take a look at the trace of an algorithm like this. I don't think it's going to be a big surprise to most of you, but nonetheless, it is important to take a look at it. And this is also the first time that I have to give you a precondition. Okay? So I will show you, how to run different test cases through an algorithm. Okay, if x is greater than y, then x gets the value. Z gets the value of x, else z gets the value of y, and if, and give these guys y numbers. And I also use indentation in this class. And fortunately, I forgot to turn on the toolbar for that. Or maybe it's just over here. Yep, that's right. Okay, there we go. Can anyone kind of guess at this point why I have to do the indentation? Why do I have to move those lines kind of one little notch to the right-hand side? Sorry? Well, so it's easy. So the if, else, and the end if stand out. Okay? And you will see later on, why indentation is very important in programming. But in this class, for now, I'll just say that, well, we'll explain that later. Just like with the other one, I use new window to open up a new window of the same document. I use sheet 2 as one of my test cases. I will need how many columns in this case? 4 columns. Very good. 1 column for line number, and then 3 columns for the variables. So we have line number, we have variable x, y, and z. Now, for an algorithm like this, I have to give you a precondition because you cannot compare an unknown to an unknown and know which one is bigger. So I have to give you a precondition. So I give you like 5 for x, let's say 2 for 2, 2 for y, and then a question mark for z. And then we'll go ahead and run the algorithm. On line 1, now this is also a time where we need one additional column. The additional column that I add here is just generically called comments. But I want a comments, or I want a column comments so that I can explain why I take a particular path instead of the other one. In other words, every time you evaluate the condition of a conditional statement, you have to say something in the columns, in the comments column, because you want to tell me whether the condition is true or not. So in here, I'm going to record x is greater than y is it true or is it false?
True.
It is true. Very good. So what is the next line? Oh, wait. There's one more thing. What happens to x?
X is still 5.
X is still 5. What happens to y?
Y is still 2.
Exactly. So nothing happened to the variables. When you evaluate a condition, it does not change the value of any of the variables. So they're all exactly the same. But in this case, where should I go? Should I go to line 2 or should I go to line 4?
Line 2.
Line 2. Very good. And after the execution of line 2, what happens to x?
It's the same.
No change. What happens to y?
Same.
No change. What happens to z?
5.
Z will now have a value of 5 because I'm copying the value of x to z. Now here's the big question. What do we do after this?
5.
It's over.
Okay, if you write 5, I won't complain, at least for now. But the proper way to say it is just to say post because we are actually done. Okay? Now, I'm just a little bit picky here. Line 5 is really what we call just a marker. It marks the end of the conditional statement, but it doesn't do anything at all. So that's why we don't trace line 5 at all. We just say that there's nothing to do after line 2. Okay? But in your trace, if you indicate line 5, I won't take any points off. It's just that that particular line of trace is not doing anything. Okay? So this is what I call one test case. In other words, I am giving this particular algorithm a run to see if it does it correctly for this very specific case when x equals 5 and y equals 2. I can give it another test case in, say, sheet 3. So I would use exactly the same format, one column for comments, one for x, one for y, and one for z. And this time, I will try, x to have a value of 2. X has a value of 2, y has a value of 2, z starts with some unknown value as my precondition. Because I want to see, how to trace the algorithm when the condition is false instead of true. I still have to go to line 1. Oops, I made a mistake here. Because column B should be line number. And the pre goes here, and the line 1 goes here. That goes away. That goes away. That goes away too. Okay, sorry about that. On line 1, what will happen to x, y, and z? Nothing, right? Because we are only evaluating whether x is greater than y is true or not. So x still ends up with a value of 2, y still ends up with a value of 2, z is still unknown after line 1. But what I really need to do is to go to comments and say x is greater than y is, this time it is false. Okay, very good. What do I go next? Where do I go?
Is it post? Are you done?
Well, let's see. If you look at this code and look at the picture, they are the same. So I was at this point, I evaluated whether x is greater than y, and the answer is false. So I have to follow the path that is labeled false. And where do I end up at?
Line 4.
I end up on line 4. Very good. If you say line 3, I won't take any points off, but once again, line 3, which only has a word of else, does not really do anything. So any line that doesn't do anything really useful, I don't trace. And as a result, I go to line 4 right away. Line 4 is an assignment statement. After the assignment statement, nothing happens to x, nothing happens to y, but z will get the value of y, which is 2. And after line 4, where do we go? Post, because we are all done. Okay. Are there any questions about how we trace a conditional statement? No questions? This is all good? Okay. So I will go ahead and save this file into today's folder. If you don't see a zip file in Moodle for today's notes, remind me to upload it. Okay. Sometimes I go home and I got stuff to do and I forget about it. So you can always just remind me and say, well, about the files that we have captured for today. When is it going to be uploaded? So we'll call this max2 because it is finding the maximum of 2 variables. And the notes online actually has full explanation of everything that I just talked about, just in a slightly different way. So if you read this part here, there's also a picture. This is a general picture of a conditional statement. You have a condition that has to be evaluated before the branch. The branches are labeled true and false. You have one side for the then statement. You have the other side for the else statement. But these two sides will merge before they exit, before you move on to the next statement. So basically the same thing that we have talked about, and this is the specific picture that we have captured on the left-hand side of the whiteboard. So there's nothing new at this point. The next slide starts to talk about logical operators. In other words, what do I do if I want to find the maximum of 3 variables and update z with the maximum of w, x, and y? When my website is busy trying to load the page, let me give you an example. W equals 2, y equals 1, z equals, whoops, I skipped one variable. Okay, x equals 1, y equals 3. If I want z to become the maximum of these 3 variables, what should it be? It should be 3. Okay, now this is very good. I heard somebody said y, which is technically correct. But in an algorithm, you cannot say that z is tied to the value of y. You can only copy the value of y to z. Okay, so that was a very good comment when I heard oh, z has the same value as y, which is true. But in an algorithm, you can only state the exact value. You cannot say that z equals to y, even though that's mathematically correct. Okay. Well, in order to do that, okay, this is why we need to talk about logical operators. Because what I can do is I can say, well, I can kind of use a template. I can use an overall structure that looks like this. I know that sometimes w can be confirmed as the maximum of the 3. If I can use C1, condition 1, to confirm that w is in fact the maximum, I only have to copy the value of w to z and I'm done. Well, but what if C1 is not true? What if w cannot be confirmed as the maximum of the 3? Well, let's go ahead and try C2. C2 will confirm that x is the maximum of the 3. If C2 is true, then I can just copy the value of x to z. If C1 is false and C2 is false, what does it mean? What does it imply?
Everything else.
It implies that w is not the maximum. It implies that at the same time, x is not the maximum. You only have 3 variables, so which one has to be the maximum? Y has to be the maximum. So that's why in the very last case, I don't even have to say else if blah, 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 because if C1 is false and C2 is false, I have no choice but to pick Y as the maximum of the 3. Is that making any sense? The overall structure itself? So now the big question is, what do I say in order to specify C1? How do I confirm that W is the maximum of the 3 variables? How do I confirm that X is the maximum of the 3? That's the question. Well, attack, that's pretty easy. We can just say that if W is greater than X and W is greater than Y, then we can confirm that W is the maximum, right? But then we'll be using something that we have not talked about. What would that something be? The word and, A-N-D. So that's why we need to first talk about the logical operators, which is nothing really new. We have used these operators, since elementary school. We just don't call it, conjunction, disjunction, and negation. I guess in a grammar class you still use conjunction, the word conjunction. But in logic, a conjunction is very specific. A conjunction is an operator that has two sides. Just like addition, multiplication, division, it's an operator that has two values to work on. The whole expression is true if and only if both sides are true. In English, the conjunction is usually the word and, A-N-D. The mathematical symbol is kind of like a caret or a little TP or inverted V. And sometimes I would use that representation. In C and C-derived languages, the conjunction operator is ampersand, ampersand. This is not a typo. It is really a double ampersand. In Pascal, SQL, and Visual Basic, the operator is just spelled out as AND. In this class, when you need to specify the conjunction operator, just spell it out as AND. That's the easiest way to do it. I can define conjunction using this little table here, quote-unquote table, because I can say that true and true is true, false and true is false, true and false is false, false and false is false. That completely defines the conjunction operator. Well, I cannot do something like this with addition. Why can't I do something like this with addition? Well, think of all the cases. This is enumerating all the possible ways to use conjunction, right? But can you enumerate all the possible ways to use addition? Think about it. You can enumerate certain cases. You can say 1 plus 1 equals 2. You can say 1 plus 2 equals 3. You can pick any example, any pair of numbers. 423 plus 26 equals 449. But can you ever give me an entirely complete list of every single thing that can be added and the result of the addition? You cannot. Why can't you? There's an infinite number of integers or natural numbers. So there's no way I can do something like this, enumerating all possible combinations with the addition operator. And that's why Boolean logic is so easy. Because with Boolean logic, what can be on this side of a conjunction? It has to be a Boolean. It has to be a true, false value. What can be on this side of the conjunction? Same thing. It can either be true or false. So as a result, there are only 4 possible cases that I have to think about. When this is true, this can be true or false. When this is false, this can also be true or false. That gives me a total of 4 possible cases, which are enumerated here in this quote-unquote table. So that's why Boolean logic is actually a whole lot easier to deal with than arithmetic, because the number of combinations is very limited. You can enumerate everything. The next slide talks about disjunction. I don't know why my website is kind of slow right now. The disjunction is the English word or. Okay? And in terms of mathematics, it is the operator looks like uppercase capitalized B. In C and C++, it is known as the double bar operator. In Pascal, SQL, and Visual Basic, you simply spell out the word or, O-R. The characteristic of or is almost like the opposite of and. Okay? The result of or is false only if both sides of the or are false. False or false is false. But for every other case, if at least one side is true, the whole thing is true. Okay? Are we doing okay so far with this? Okay. So now we only have one more to go, and the last one is easy. It is negation. Negation is the English word not. When you use the word not, you mean negation. This operator only has one side on the right-hand side. A negation of expression is true if and only if the value on the right-hand side is false. Okay, which is another way to spell out the truth table here, but I'll just keep reading here. The mathematical symbol is, it looks like a little cliff, okay, the edge of a table or something like this is a horizontal bar followed by a vertical drop. In C and C-derived languages, the operator is the exclamation point. In Pascal's SQL and Visual Basic, the operator is simply spelled out as NOT, not. Okay? And this one is easier to define because it only needs to rely on one value for the operator to be defined. Not true is false, and not false is true. Are there any questions about negation? Are there any questions about conjunction, disjunction, and negation? Okay, very good.
What's the symbol
Yes.
again for purposes of pseudocode for disjunction?
For disjunction, you just spell out or.
Oh.
Yep. Now, let me ask you one more question. Remember this ampersand, it means logical and in C and C++. Vertical bar means logical or in C. The question now is, what if I forgot about this and I use a single ampersand in C instead of a double ampersand? It means bitwise AND. Okay, there's a thing called bitwise AND in C, which is related to logical AND, but not exactly the same as logical AND. So when you write a C program in the next class, you accidentally use a single ampersand instead of a double ampersand. It is possible that your program works in some cases and not work in other cases. You use GCC to compile the program, it works. You use Microsoft C compiler, it does not work anymore. Okay, so these operators are very tricky because of the way they are defined. When it is a logical operator, you always use double ampersand. When you want to use logical OR, you always use double bar because there's also a bitwise operator of a single bar. So syntactically, they are all correct. But in terms of what they do something that is similar in most cases, but not exactly the same. So these are the worst kind of mistakes to make because one, it is not a grammatical mistake. The compiler cannot catch it. Two, they look almost the same as the correct version, but they are not. And three, your program will behave correctly for most cases. Okay, and those are the worst kind of bugs to make because the program, you cannot catch these bugs easily. So you have been warned about all these operators. Don't you guys have a question like how come C is so obscure? No one feels that at this point that C is obscure already. No. Well, C is a programming language designed by hackers, really experienced programmers for hackers, really experienced programmers, which are themselves. It was never meant to be an instructional programming language. Okay, and yet it is now, and that's why you guys will have to pay attention when you're in the C class. Now, let's go back and see if we truly understand the comparison operators. Tech, we know that stuff since elementary school, and also the logical operators. But tech, we know that stuff since elementary school too. Okay, let me give you what if we only have logical operators and a single comparison operator. We'll just pick less than. Can we define all other comparison operators? In other words, I give you just the operator less than. Can we define all the other comparison operators using less than and all the logical operators that we have defined so far? That's the question. Let's think about it. Well, the trivial case is less than itself. x is less than y is equivalent to x is less than y. No problem. We can this is easy. What about x is greater than y? How do we use less than to express exactly the same thing? Just flip the order. Very good. Easy enough. What if we want to express, well, let's pick this one. X is different from y. Now, just because I use this particular representation to be not equal to, is already telling you how to express it. How do we express x is different from y? What about x is less than y or y is less than x? Wouldn't that be the same thing? Okay, very good. That's not too bad. What about x is less than or equal to y? How would you express that using the logical operators and just less than itself?
Put x is less than y and then parentheses x is equal to 1.
What about this? Y is not less than x. Do they mean the same thing? When I say x is less than or equal to y, doesn't it mean exactly the same thing as y is not less than x? They mean exactly the same thing. Oh, that's kind of cool. Okay, x is greater than or equal to y. Oh, that's easy. We just flip the order. What about x equals to y?
X is not greater less than y and y is not less than x.
Exactly. Now, you just spelled, you had it correct, but I want to emphasize, not only do you have to use negation, you also have to use conjunction along with the negation. So it becomes x is not less than y and y is not less than x. Okay? So I'm hoping that you guys start to realize the power of logical operators. Because with one single comparison, less than, I can now define all the other comparison operators. Because now I have logical operators. Yep, go ahead.
So it doesn't matter which order you put, like say x is not equal to y, the x and 2 bars. And we put instead x greater than y or y,
No, the order of these two can be flipped because disjunction, okay, if you think about it, conjunction is commutative. What is commutative in algebra? Come on, my 4th grader knew that.
It doesn't matter. If it's switched, it still comes out.
Exactly, you can switch the two sides and they come out the same way. Conjunction is like that. You can switch the order. Disjunction is like that too. You can switch the order as well. Okay? So your reading assignment for this week, I know you guys are trying to get to the next class. Your reading assignment for this week or for today is at least finish conditional statements. If you have time, move ahead and start on loops. Okay? Because loops is also very important in programming, and it gets a little bit tricky because we have a way to go back to an earlier point of execution. So it is conceptually a little bit more tricky than conditional statements. So once again, finish the entire module of conditional statements, and if you have time, start on loops, because we will have homework assignments on at least conditional statements on Thursday. Okay. I'll see you guys on Thursday.